Hey guys,
1
Pause
minute.
25 here, watching the
Report
launch.
range status.
Range green.
That's good to hear, Joshua,
That
right
means
there.
public safety there is accounted for, the FTS system. There you see on your screen a beautiful shot. The skies look great. There is little wind happening. You'd be able to see more of the venting. If there were wind, the trail of that venting. So we're ready to go.
And actually, that's an
40
important
seconds.
point. The reason we don't see that
Stable
venting
at
is
step
the
3.
vent valves have been locked up to put flight pressure into the tanks. And as we just heard, they're stable at step 3, which means the tanks are ready to go. And here at about 5 seconds, we will
28
hear
seconds.
the team
ECS reduced for launch.
give their
Roger.
final go.
25 seconds.
Status
Okay,
check.
so yeah,
Go Atlas.
Go Centaur.
Go Mars 2020.
There
yeah.
we go. We are
watching
ready
launch of
to go
Mars
lift off this morning,
2020, shut the fuck up. To obviously Mars carrying the rover Perseverance. and
7, 6,
helicopter Ingenuity.
5,
4. Engine ignition. 2, 1, 0.
2.
Release.
And
Liftoff. This Nautilus 5551.
Continues. The perseverance of humanity launching the next generation of robotic explorers to the red planet.
This Nautilus 5551 meaning 5 solid rocket boosters.
And
Fi-
Atlas TU has gone to closed loop control.
Well, 5 meter fairing, 5 solid rocket boosters, single Centaur RL-10 engine. This mission's going to be
Coming up
about
on 30
an
seconds
hour
into
long.
flight, the RD-180 is throttling down
From
as expected.
liftoff
Engine response
to-
looks good.
Vehicle is
And Mach 1
supersonic
Atlas
there.
5 is now
You can see a bit of the Mach on there. The mission's going to be about an hour from liftoff to Mars 2020 separation.
And passing 45 seconds into flight, vehicle is now passing through max Q, maximum dynamic pressure.
What's going to work is the Centaur is going to just put into a preliminary orbit. Then about 50 at T
And
plus about
passing
50
1 minute
something
into
minutes.
flight, the RD-180 is throttling back up as expected. Engine response looks good.
So
At
yeah,
this
about-
time in flight, the SRB chamber pressures remain nominal. The RD-180 pump speed and fuel injector pressures are responding well to demands on the engine.
So at about T
Standing by
plus
for SRB burnout shortly.
so at about T plus 50 something minutes is when there's going to be second engine ignition, a few minute burn.
And we have burnout on all 4 SRBs. Burnout pressure signatures look good.
Boy,
Standing by
there's
for
5.
SRB jettison shortly.
Or is there 4? As far as I know, there's 5. Well, we shall see soon enough, shan't we?
And we have good indication of SRB jettison of all 4 SRBs.
Is this a 5?
And the vehicle has gone to closed loop guidance.
Because, like, Curiosity was a 551.
Vehicle body rates are responding nominally at this time.
I'm actually looking this up because I thought this was a 551. If Google loads on my phone, but yeah. So basically, you've got another rover.
And coming up on
Curiosity
2.5
style,
minutes
basically.
into flight, the RD-180 is throttled down slightly as expected. Engine response continues to look good.
That's to maintain a constant
At this
acceleration.
time, the
basically.
vehicle is 50 miles in altitude, 85 miles downrange, traveling at 6,000 miles per hour.
I'm sorry, 50 miles in altitude? Did someone fuck up? It says here downrange 80 and close to 200 miles an
And the
hour.
Centaur reaction control system is now pressurizing to flight levels.
At this point I'm just like, what? What are you talking about? Okay, no.
And just past 3 minutes into flight, the RD-180 is now throttling to maintain a constant 2.5 G acceleration limit for payload fairing jettison. Engine response and vehicle acceleration look good.
Oh yeah, I also point out this program has this launch has the send your name to Mars thing, where you could, there's separation, fairing, and then there's going to be the...
And we have good indication of payload fairing jettison and Centaur forward load reactor deck jettison.
Yep, that thing. So yeah, this was one where you could send your name to Mars, which I did.
And the RD-180 is throttling back up to attain a 4.6 G acceleration. Engine response continues to look good.
Wikipedia. I don't want the NASA thing. I want Wikipedia because then I can find out which.
And Centaur has begun the boost phase chill down sequence to thermally condition the RL-10 for operation.
Which means they. I don't know if they flow I think
Standing by for BECO shortly.
I think they flow hydrogen through it so that it doesn't get some shock, basically. When the cryogenic fuels run through.
BECO is the
Booster engine cutoff.
BECO's the call for booster engine.
And we have BECO, booster engine cutoff,
There we go.
standing by for stage separation.
That's a view of the interstage. And separation.
And we have good indication of Atlas Centaur separation.
And RL-10 ignition by the looks of things.
So there you're seeing live footage
And we
from
have
the
MES
rocket.
1. RL-10 operating parameters look good.
Oh no, it is a 541.
Chamber pressures are
Whoops.
stable.
And the 541 is one that I don't recall having launched that frequently.
This
Yeah,
will
it's
be
only
the
6
first
of
of 2 burns for today's mission. This first burn will be approximately 7 minutes in length.
Okay, my bad. Yeah, that is a 541, not a 551.
So Mick, that's pretty exceptional footage there. That's live video. We will see that switch over shortly into an animation that kind of helps let us know what's happening with the rocket. But right there, a beautiful liftoff. Fun to feel that rumble in the building here as we proceed towards orbit and then towards Mars destination.
Yeah, absolutely. It was great watching an on-time liftoff of the Atlas V with that little over 2 million pounds of thrust. Cleared the tower in roughly 5 seconds. Josh, you and I worked the InSight mission, and if you recall, that mission on the West Coast took about 17 seconds to get past tower. So with those 4 solids
Oh, never
today,
mind.
this thing really got out of here and on its
Curiosity
way.
was 541.
As we hear from Jesse,
Chamber pressures.
everything's looking nominal, and all vehicle parameters are within the design limits, and we're getting ready to come up on a main engine start for that first burn that Jesse was talking about.
Yeah, so recapping this countdown to Mars, the stations began to be filled up this morning just after midnight. Preparations, fuelings, powering up, all the way through that liftoff that happened. I think, Mick, it wasn't precisely on time. I think you said it was like 10 milliseconds early. So it's pretty much dead on.
Yeah, dead on. This team does a great job. As I said, they're very focused, very disciplined. As Tori also said, courageous. They have done a lot of work to get us to this point today through this pandemic, changed how they did some of their work, made adjustments as needed. A lot of cleaning, a lot of things, a lot of wearing their face masks, doing all kinds of things. And so this is an exciting time, not only for the JPL team in Mars 2020, but everybody that's worked this mission, and for the country and the agency. So this is exciting to see. We still have a long way to go, Joshua,
Yes.
before spacecraft separation.
Yeah, we had a really quiet countdown today, which is phenomenal, that we got off the ground on time. And we are proceeding now that we are in the middle of the first burn. It's tough to make out, but that engine is lit and it's firing. So we are in motion. There you go. There's that animation we talked about.
The telemetry there as we switch to a TDRS compatible data format.
TDRS
Overall telemetry quality is very good.
The space tracking system. So there you go. This is not an actual video, but this is an animation that's driven by real data. So although we're not actually seeing the engine on screen right now, we can see that the engine is lit, and that is driven by the data that says that the engine is truly lit and we're in this burn.
Yeah, the launch vehicle continues to send telemetry to the launch team via the TDRS network, as you mentioned, and that allows them to continue to watch what's going on and make sure all their sequence of events meet their timeline. We continue on a nominal flight this morning. This first burn, as we heard earlier, will be about 6 minutes. This will get us into that park orbit around Earth.
That's the word.
Allow us to get on our way, and then get into that approximately 30-minute coast period that we're going to have.
8 minutes into flight, beginning to see the Centaur PU system balance out mass errors. Seeing very stable body rates in the Centaur.
So we've mentioned 5 teams at play, and although if you were watching, hopefully you got a chance to see this in person, if not on camera, it's easy to kind of say, oh, it's over, like job done, but all 5 of these teams still very much engaged, still very much focused, because there's a lot of work ahead as we proceed through this first burn, and then a coast phase, like you mentioned, Mick, and then a second burn, and then spacecraft separation and the acquisition of signal from Mars 2020. So a lot more coming up here. Mick, I know for Launch Services Program, you guys manage the launch. So what does that mean? I mean, this is you guys' work in action right now.
By the way, that's the fifth team that we didn't get to mention. We talked about JPL, we talked about DOE, we talked about United States Space Force, and United Launch Alliance. LSP, we are like the brokers to select this launch vehicle and help with manage this mission. So we get our spacecraft customer, the JPL folks, they come to us. They have some certain requirements that they need for this mission. The Launch Services Program made up of engineers and flight analysis folks, and they look at everything, they help define those requirements, and then we go out and procure a vehicle from a commercial partner.
Okay,
in this case, it was the Atlas 541 for the Mars 2020 mission that was needed for performance, right? As you and I have talked over the last several days, Josh, one of the things that was important for us to look at was that performance, to be able to get Mars 2020 onto that transfer orbit into solar orbit to intercept Mars in 7 months. It's kind of analogous to a football game, right? With a quarterback trying to throw a pass downfield. You need a quarterback with a lot of performance who can get that ball down there where it needs to be, so the receiver can intercept that. In our case, 7 months later.
There you go. Yeah, it's the longest football pass ever. The Earth is the quarterback. The Atlas is the quarterback's arm. Perseverance is the football, and Mars is the receiver.
That's exactly right.
That
what we also
means
talked about is
nothing
that
to me. I don't know anything about American
you could
football.
launch to Mars
I
at
don't
any
know anything
time
about
if you had a
it.
rocket that was
It's
powerful
really.
enough. But this is the launch period every 26 months or so, as we've talked about, that makes
Most
the
efficient.
most sense because you require the least amount of energy to get to Mars because it takes a lot to get there. Obviously, like the Atlas 541 is a workhorse.
Yeah, as Tori said, it's their Dominator. Right?
There you go.
I love that name for the Atlas 541. But we heard Jim Bridenstine, our
I mean,
NASA
the Atlas
administrator,
5,
tell
yes,
us
the
that
541,
if we didn't make
no.
this launch period, we would be down for roughly 26 months,
it's
right?
tough.
So the period started July 17th and goes to August 15th. Today, July 30th, was one of those launch opportunities that we had. We had a 2-hour window, and within that window, we had several opportunities.
25, actually.
Yeah.
25 opportunities.
And we launched at the beginning of the window on our first opportunity to get Mars 2020 going on its way. And that, that sounds like a lot, and it is. The flight analysis group, both at JPL, LSP, and ULA, did a lot of work to pick out those target sets and figure out where we needed to be. So they've done a great job, and we'll see how this mission continues.
So, Mick, tell us about the
Perigee is
2
positive.
burns required here, and we're actually coming up on the end of the first one.
I don't know how high
Ultimately, a lot of people probably,
Perigee's
and
gonna
myself included at some point,
There
just
we
like,
go, shut
why
down.
wouldn't you just keep firing the engines? Just fire all the way through and get to
Because
Mars
it's
in
not
one
that
shot.
simple.
So the first burn gets us into that park orbit we talked about. We've lifted off, we've left Earth, we've got into a park orbit around Earth right now.
As you can
And
see,
while we're
the
in
satellite is
that
in-
park
vehicle
orbit,
is in a park
we will
orbit.
perform some maneuvers to kind of roll Mars Perseverance and the Centaur and coast during that time, basically setting itself up looking at the sun and away from the sun to control the thermal environments that are on Mars 2020 during this coast period. That coast period will allow us to coast around into the position that we need so that we can have that second firing to get the velocity needed to head off into Mars.
Yes, and we will be back for that second burn in just under 30 minutes now. But for now, there's more to learn about this mission and all the amazing science that's involved.
Yes.
Daryl, back to you.
But I'm not going to record all that because, no, I'm Boston25. See you for the second burn.
There we go.
guys,
Awesome. And
there's
again, that
main
animation
inside
there
too.
being driven by actual telemetry data coming from that rocket. So that's a phenomenal
RL-10
sign.
pressures
And it,
stable
again, I
and
think that
nominal
it's
at the beginning
tough
of the
with
second
these
burn.
images. Perspective and
8-minute
scale are so
burn, I
important.
believe.
This vehicle is in Earth orbit. It's not near anything, so you can't see the acceleration of what's happening right now.
And you
But
can't
for
see how
8 minutes,
big
it's
the
going to be
vehicle
picking up
itself is.
speed.
Yeah, this is the burn that gets us really moving
Just
in
keep
the
an eye on the
direction we need to
aperture,
go,
so
that fast velocity
increases.
that we need to get out of our park orbit and head on our way to Mars. Of course, Centaur and Mars 2020 are still
And the TU
together.
system is in
And
closed loop
as
control
we're
as
hearing,
well.
everything is looking nominal on this fire
controlling
so
mass
far.
errors to
Main engine
near
start
zero.
was good, and the
Seeing,
firing
good
is
response from
going
the
well,
TU
nominal, as we see in the animation there.
Fantastic. So this is rocket science, and it's not easy. We actually want to bring in now, we have a special guest. This is Dr. Denton Gibson, excuse me.
Yes.
He is a rocket scientist. His official title is Senior Vehicle Systems Engineer. Denton, how are you doing?
I'm doing well. Thanks for having me.
Yeah, did you enjoy that? Obviously, you got to kind of spectate. A lot of days, you guys sitting on console, you have to kind of focus on your computer, but you got to see this one
Yeah,
today.
as you can
Oh,
see, the
yes, and it
apogee
was a beautiful launch
is,
today.
past
Yeah, nice
2,100
sunrise. Hey,
kilometers.
tell us about your role with LSP. I was not making up things when I said you're a rocket scientist, but what exactly do you do?
So as our role in LSP, as a vehicle system engineer, we are the engineering team lead for a lot of the rockets that we launch our science missions on. And we are responsible for the oversight and insight into these launch vehicles for the NASA.
That's awesome. And I know in the past you've supported a variety of vehicles. Tell us a little bit about the vehicles that you have supported and the ones you're focused on today.
Yeah, so some of the vehicles I supported in the past is the Delta II, which was a long-time workhorse for
It has since
our
been
science
retired.
missions, as well as the Pegasus and Taurus/Minotaur C. And right now I've been focused mainly on the Falcon 9 and Falcon Heavy.
Yeah, awesome. So obviously not focused on the Atlas V, but a lot of that experience and the process is the same. I want to take a moment to pause and say Denton's there at Hangar AE. That's the NASA Launch Services Program's hangar. They're very proud of that. We call it the telemetry center of the universe. That's where the data for today is flowing. But I wanted to also ask you, is the process the same for all these vehicles? When we talk about the telemetry and these sort of processes of getting from Earth to Mars, does Falcon 9 experience translate to Atlas, or are they completely separate?
So the overall process for many of these launch vehicles are the same, whereas you ship stages to the launch site and assemble the launch vehicles by stages. So in that sense, they're the same, but there's a lot of differences between the launch vehicles that may change that process a little bit. But in general, the processes are the same.
Yeah, and Joshua, I was going to say, Denton, I worked with Denton quite a bit over the years, and he talks about the different vehicles he's worked on. But Denton is one of my senior vehicle engineers in LSP, and so although he's not totally supporting Atlas V today, he does have experience with Atlas V, and as he said, things are very similar. So using his experience, we're able to train and bring on new generation of engineers, and Denton's been a huge part of that to allow us to grow our bench, if you will, to start working commercial partners.
Yeah, awesome. So Denton, tell us a little bit about kind of what's involved, what goes in behind the scenes, what's the rocket science of going from Earth to Mars, this maneuver to go into solar orbit?
Yeah. So a lot of the things that happen behind the scenes it's a lot of analysis work done by our analysis teams. I mean, it's months and months of analyses that are performed based on the orbit insertion, the performance of the launch vehicle. A lot of modeling and simulations is done to be able to get to this point to where we can transfer from Earth orbit into solar orbit.
Awesome. And obviously, you're a rocket scientist. That's for a lot of people, that's like the pinnacle. That's like, hey, I want to be a rocket scientist. So where do you go from here in your career? Because obviously, like, I'm sure there's lots of things that you'd like to go and accomplish.
So, going from here, I mean, one of the coolest things about this job of working in the launch services program is working the launch, right? I mean, who doesn't love a launch, and who doesn't love working launches?
Yeah, we love them. We love them. Excitement this morning, right, Denton? We got to see that's what it's all about.
Of course. So, one of the ideal jobs would be a launch director, because you get to work all the launches. I mean,
Very
how cool
good.
is that?
No, yeah, that's true. And I guess you get to, is it right to say you call the shots, or is it that the buck stops with you, or how would you say that?
I'd say the buck stops with the launch manager. As today we talked, right? Omar Baez is our launch manager for Mars 2020, and he had to poll the team and make sure everything's ready to go. So the buck does stop with him right there on today's launch. And as Denton says, I think there's a lot of people that would love that job, and Denton's definitely looking at that next step. So I guess we need to give Omar and his assistant launch manager, Tim Dunn, a heads up.
Yeah, there you go. Dr. Gibson.
Dr. Gibson is
Up
on
and
the
coming.
way. Yeah.
Awesome. Well, Dr. Gibson, before we let you go, give us a real quick snapshot. I know you have a mission coming up later this year. What are you working on?
So we're supporting the Crew 1 launch coming up, so we're helping commercial crew out with that one, as well as Sentinel-6 as far as the LSP missions. That's coming up later on this year. And so we're excited about that one.
Yeah, a ton going on. Dr. Gibson, appreciate you. Thanks. And I want to take a special moment on the commercial crew note to comment. We've got a big day coming up.
Yes.
Pending weather. There's a tropical system that might kind of get in the mix here. But we have a tropical system that could create some problems. Otherwise, we've got Bob and Doug from Demo 2. They're coming home on August 2nd.
Yes, I was going to say, Joshua, that's important for us also in LSP. Denton was my lead VSE along with a few others that are in the group that worked that mission with the Commercial Crew Program. And so it's really important for us to be able to support other programs within the agency to make these things happen. As we launch Mars 2020 today, which is another step for us getting humans to Mars, right, is getting humans launched off of Earth soil was a huge step for off of American soil.
Yes,
was a huge step for us.
Yeah, and so talk about that really briefly with LSP. Obviously, Denton there, appreciate him and his contribution, and you working towards Commercial Crew, but also supporting Artemis, which is also part of that path of getting humans to Mars someday. Artemis is about learning to live on the moon to sustain a presence there with the eyes on Mars. So how is LSP supporting even Artemis?
Yeah, one of the things there is the Gateway program, right? Deep Space Logistics that is working a lot of that. And so LSP is in the works of supporting Gateway and helping them work with the commercial partners that are providing the rockets for those kind of missions that are out there and future things. One of the cool things about working with the Launch Services Program is that we work with all of our commercial partners, SpaceX, United Launch Alliance, Northrop Grumman Space Systems, and of course some up-and-comings. You may have heard some, right?
It is
like
a growing
Blue Origin.
field. Yeah.
It's definitely a growing field in the aerospace industry, and LSP takes pride in working with those commercial partners to figure out what we can do for NASA and the country.
Awesome. Yeah, it is an exciting time for spaceflight. The commercial spaceflight industry is booming. There's always new things happening. If you keep an eye on the news, you will see new things. We're getting word now that the engine cutoff here should be happening momentarily. Once we see that happen, we'll have roughly, I believe it's 5 minutes until we actually see the spacecraft separation occur. So we're going to stay with you through that, but want to kind of just preview that for you, that hopefully on screen here you should be seeing that engine cut off, and that's completely expected. That's a nominal operation.
It's a nominal operation. We'll hear from Jesse Gonzalez, who's looking at the launch vehicle telemetry and watching the animation there. So let's listen in for Jesse here.
There's Miko.
And there's the call, and there's the animation, again, modified based on data. So
shutdown parameters
let's talk about communication for a minute, Nick, because it is not an automatic thing.
You know, I'm just going to shut this off. They were talking about how integration is similar with all vehicles when the guy said he's most familiar with Falcon Heavy and Falcon 9. One crucial difference. Atlas and the Deltas, they're integrated vertically. They're put together, they're stacked on top of each other. The Falcon 9 is integrated horizontally. It's built, put together horizontally, rolled out the launch pad, lifted up. Just one crucial difference.
Which, by the way, is also used for the ISS and will be used hopefully for the landing with Doug and them.
Yes.
So getting off the ground today was great because we could deconflict some of that TDRS usage, right? But TDRS is very important for us to be able to get the telemetry from the launch vehicle back down to Earth here. And then, of course, when Mars 2020 separates and it gets on its way to Mars, then the JPL team will take advantage of NASA's Deep Space Network, which has been around for a long time, to be able to transmit commands and data back and forth to the Mars 2020. So it takes a lot of folks to work those, and the TDRS and Deep Space Network are very important to not only the science missions, but human space flight also.
Yeah, and I think the coordination of that is something that people don't get a chance to understand much, because as you said, we're using TDRS for crew return, we use TDRS for space station, and TDRS is not an unlimited resource. We have a good number of TDRS satellites in orbit that help us do these things, but it is a coordinated effort across the globe, because we even have ground stations in Australia, I think. Yeah. Where are all of our ground stations even?
We have ground stations everywhere, not only here in America on the West Coast and East Coast, but then you get into South Africa area, Australia, you said. We have several ground stations that catch up different things for missions, but of course in orbit, TDRS and the Deep Space Network are very important. And as you said, there's not an unlimited amount of resources there in the TDRS network. So we have to coordinate those things within the NASA agency and with our commercial partners when they're used for our launches. And again, that's another part of what NASA does as an agency.
Yeah, so just on that note, kind of thinking about around the world, currently this spacecraft is roughly over the South Indian Ocean. So that's just thinking about how fast we're moving, just Australia, the amazing
Malaysia, all that area, I think.
World of spaceflight. It's just hard to put into words sometimes of we're literally flying around the Earth and we're already halfway around it. And so I want to talk actually about planetary protection some more. I know we heard about that a little bit from Moo, about how they're working to protect Mars from contamination, so to speak, just putting things there we don't want, and we have to consider that, or ULA has to consider that when they're flying to Mars and delivering the spacecraft.
Yeah, it's a combined team. ULA, JPL, LSP had to look at that for when we get ready for spacecraft separation here in about a minute, right? One of the things we talked earlier is that Centaur and Mars 2020 are on the same path towards Mars right now. So once we separate, Centaur will do a CCAM maneuver, or what we call a contamination and control avoidance maneuver, and then blow down what's left of propellants in its tank. And by doing that, we have now put Centaur on a different track so that it will not intercept Mars or interfere with Mars 2020 at all for approximately the next 50 years.
Yeah.
And that took a lot of work by the JPL team and the launch team to make sure that would happen. So again, another planetary protection maneuver that had to be done.
Yeah, and I understand from the telemetry experts in LSP that this rocket actually, after the second burn, is not actually aimed straight at Mars for that reason. It's actually aimed slightly off of Mars. And so Perseverance, Mars 2020, will redirect itself just slightly. We're not talking about over 7 months. A little bit of difference here makes a lot of difference later.
Absolutely. And Josh,
yeah.
We heard Jesse telling us that Centaur is spinning up. This is the maneuver right prior to spacecraft separation, where we get into a slight roll to give Mars 2020 some
stable Centaur tank pressures,
stability.
very good performance from the RCS system, and stable indications from the avionics systems as well.
That means I think we are very close to.
So RCS there, the reaction control system, that's those small, the series of those small engines that you see firing around the spacecraft. Those are used for that in-flight operations that they need. The rolling activities, as Mick's saying, is basically providing stability to the flight of Mars 2020 as we go forward. Tell us about actually.
And we have successful separation of Mars 2020 with the Perseverance rover.
There we go.
Awesome. We got some nice applause there. That is a big moment. We are hoping to get some live video back from that because of the time delays with communicating with things in space. We don't have it at this instant. We're hoping we'll get to see that here in a few minutes, and we'll bring that to you if we do. But tell us about the separation maneuver, because the apparatus, the actual... It's a really simple design.
It's a separation clamp. We'll talk about that in a minute, but as you see on your screen right now, you see the Mission Director Center where Omar Baez and the team are. And Josh, you and I joked about this a little bit earlier, but with the pandemic and everything going on, the teams have done a great job. Normally, spacecraft separation.
2020 with the Perseverance rover, the Centaur will now perform its standard propellant blowdown sequence to inert the vehicle and complete today's flight after completing its CCAM avoidance maneuver. This will conclude today's commentary of the Mars 2020 mission. This is Atlas Flight Commentary signing off.
So that's the end of ULA's job for today.
Jesse Gonzalez did a great job with the ULA commentary this morning. But what I was saying about the Mission Director Center is normally we would see a lot of clapping, a lot of hoop hollering, a lot of handshaking.
Yeah.
But with the pandemic and everything, people are staying their distance, taking the guidelines seriously, wearing masks with this. So we saw a lot of air high fives, right?
Yes,
and stuff.
absolutely.
So that does not take away from what the team is, how excited they are. They have done a lot of work to get to this point, and that seeing spacecraft separation is awesome. So, but
and throw on top of all that, 2020 was like, here, have an earthquake.
Right.
So it's just we did it. Like we're most of the way there, not there yet.
Yeah, as you heard Omar earlier in the broadcast say, a lot of us when we started this, when the pandemic started, we kind of thought Mars 2020 might be Mars 2022.
Yeah.
But Mr. Bridenstine and the NASA agency decided to move forward. The teams found ways to do this. As we heard, they were disciplined, they were focused, they were courageous. And all that played off today with a successful launch at 750, and now spacecraft separation, Mars 2020, Perseverance and Ingenuity on their way to the red planet.
Hey, we're going to wait for acquisition of signals. Stay with us, but really fast, Mick, tell us very, very quickly about this mechanism, because we teased it.
We teased it, yeah.
How do these things separate?
So the separation system is called a Marmon clamp band, actually designed earlier by Karl Marx, one of the Marx brothers. Very simple design, but it has some spring systems in it that once the signal is sent and the bolts release the clamp band, the springs basically just give just enough force to push the spacecraft off the front of the vehicle.
Awesome. And again, hopefully we'll see that video here momentarily. But for now, we're going to send it back to you and check in for one final time in a little bit with the folks here at ASOC. But Daryl, back to you.
All right. I'm just leaving it here. That was launch of Mars 2020 on Atlas 5541. I'm Bottom 25. Goodbye.